let's just talk about identities and general solutions, because you're always going to be given one of each. All right, so the first thing that we're going to talk about tonight is the general solution of tan x equals 2 sine 2x, where cos x is negative. All right, so yes, it's maths. And I chose this question because it's out of 7, and that's quite a lot. You know, that's probably sort of the most that your questions would be out. So I don't think you'd get questions out of more than about 7. So yeah, being able to do something like this is obviously worth a lot of marks for you, and you'd want to try and get as far with it as you possibly can. So there's a couple of things going on here. All right, we've got tan and we've got sine 2x. So the first thing that we want to try and do is, what do you think? Yeah. You're welcome to unmute and talk if that's easier. What do you think the first thing is we should do here? So, Kaiser, always look for identities that you can apply. All right, so if you see tan x, write it as, yeah, exactly, can you see there? Yes, that's it. Okay, so good idea. Let's take tan x and write it as sine x over cos x. Good place to start. Okay, and that will get us, I think, one of those 7 marks. What do we do, matrix, when we see sine 2x? So this over here, what do we do with that? Yeah, exactly. That's it, Aisha, quite right. Okay, so it is. It is a sine double angle identity. So we've got 2 times 2 sine x cos x. Absolutely. So what we're ending up with here is sine x over cos x is equal to 4 sine x cos x. So now what's the next step, do you think? What do you think we should do now? So we've got a fraction on the one side. How should we approach this now? What are your ideas? Okay, remember it's an equation. You're solving, you're doing a general solution. So you're allowed to do the same thing to both sides. Yeah, so absolutely. So when you're saying divide both sides by cos, you guys are just using the wrong word. So it's not dividing both sides by cos, it's multiplying both sides by cos x. Okay, multiply both sides by cos x. Remember, the opposite of dividing is times. So either you can cross multiply or multiply both sides by cos x. It's exactly the same thing. All right, so remember this is over 1. So if we cross multiply or multiply both sides by sine x, sorry, by cos x, we're going to end up with sine x equals 4 sine x cos squared x, like so. Now what? So you're all right about getting rid of the denominator. That's perfect. What are we going to do now, matrix? Okay. Can you see there? Why are you not allowed to divide by sine? You're not allowed to divide by sine. Okay, they are equal, Kaiser. Right, now, just 1 second before we carry on, right? Can you see that? I'm very glad that you said that, okay? You are not allowed to divide by sine theta, because dividing by sine theta is not a thing. It's not an identity. It's not a mathematically acceptable thing to do, because essentially what you're doing is that you are getting rid of one of your solutions. All right, you're only allowed to divide sine theta by cos theta. All right, so the angles have to be the same for you to be able to do that, and you're allowed to do that because it's an identity. Okay, so you cannot divide by sine theta. So what I was saying to my, I think it was actually my grade 11s the other day, we were talking about a question like this. If we gave you an equation to solve, and let's say the equation was 2x cubed minus 3x squared plus x equals 0. Would you guys come along and say, okay, well, I'm going to divide by x, divide by x, divide by x? Okay, so no, absolutely not. We can't do that because if we divide by x, we're losing one of our solutions. All right, so we cannot divide by sine theta. It's not an identity. It's not anything. And we will end up, losing marks for that. Okay, all right, so I'm very glad that you said that because it's given us something to talk about. So at this point over here, all right, what we want to do is we want to collect our terms together on the same side so that we can factorize. So let's leave our 4 sine x cos squared x on the right, and let's take sine x over to the other side. Okay, so if you see something that appears in both terms, move everything, okay, so that it's on one side so that we can now start factorizing. Okay, so here we're going to take out sine x as our highest common factor, and that leaves us with 4 cos squared x minus 1. All right, so now what do you think we should do? Okay, we can't divide, so we factorized. Dividing means we would lose a solution. So the idea is, so like if you had sine squared theta minus sine theta equals 0, and you took out sine theta as the highest common factor, you'd end up with sine theta minus 1. So either sine theta equals 0, or sine theta minus 1 equals 0, in which case sine theta would be equal to 1. So we've got to do the same thing here. All right. Exactly. Equate each term to 0. So either sine x equals 0 or 4 cos squared x minus 1 equals 0. Okay, so if 4 cos squared x minus 1 equals 0, it means that cos squared x is equal to positive 1 over 4. And now we can square root. Okay, so cos x is going to be equal to plus minus the square root of 1 over 4. But now let's go up here. Look here. It's told us where cos x was negative. Okay, so they said cos x needs to be negative. So here we are going to accept the negative answer. Okay, so that means that we're going to solve for cos x equal to minus 1 over 2. Okay, how are we feeling so far? Is this making sense? Cool. So we can see, yes, I can imagine. You're very brave to still come here and do an hour of maths when you're busy writing finals and getting ready. Okay, so yeah, Neliswa and I have lots of respect for you and lots of sympathy. I understand it's a horrible situation to be in, but you just got to hang in there, okay? You've literally got, like what, 62 days until you start writing finals. Okay, you're nearly there. It's 3 months, more or less, and it's all over. You're almost there. You're almost there. Okay, and you think about it, if Neliswa could do it and I could do it, you guys can do it. Okay, you just got to hang in there and be brave and try and get as much sleep as you can and eat properly and just look after yourself as much as you can. No timelines. Okay, Cornelia. No timelines. Aisha, do you have a question? Sleep does not exist. Oh, Cassandra. It will one day. Okay, you just keep being brave. All right. You see, but at some point now, you're going to be telling Elise and I next year, these are your results, and look how well you've done. And it's all going to be worth the sacrifices that you made. Okay, so when we go back and we look at this question, we can understand now why it's out of 7 marks. I mean, look at all of this. First, we had to apply the tan identity. Then we had to apply the sine double angle identity. We had to cross multiply, get things onto one side, factorize. And now we're at the point where we are ready to find our PAA. Okay, so we've got to do 2 separate things here. We've got to do a PAA for where sine x equals 0. So when sine x equals 0, our PAA is 0. And when cos x equals -1/2, remember, you do not use the negative to find your reference. So sometimes, you may call this an RA, or you may also, your teacher might also refer to it as a key angle. Okay, so we refer to it as a PAA at my school, but it's up to you what you want to call it. Key angle or a reference angle is the same thing. Okay, so the negative is used to determine which quadrants we're going to work in. It's not used to find your PAA. So you would press Shift Cos, pop in the half, and your PAA in this case would end up being 60 degrees. Okay, so for sine x equals 0, we would consider 0 positive in this sense. Okay, 0 isn't positive, but for the sake of this in trigonometry, we would consider 0 to be positive. So that means we're doing a solution in quadrants 1 or 2. So in quadrant 1, we would say that, I don't know why I'm writing S, we would say that x, our angle, is equal to our key angle, or RAA, which in this case is 0 degrees, plus k times 360. K is an element of the integers. If you want to just write that as x equals k times 360, k is an element of the integers. There's nothing wrong with that either. Okay, you don't have to write the 0 degrees. Or in quadrant 2, so x would be equal to 180 minus 0 degrees plus k times 360. And therefore, x would be equal to 180 plus k times 360. K is an element of the integers. Okay, so there are our 2 general solutions for sine x equals 0. For cos x equals -1/2, because cos x is negative, we have to work in quadrants 2 or 3. Okay, so in quadrant 2, we would say x, our angle, equals 180 minus our reference angle plus k times 360. K is an element. Let's just move this over here. K is an element of the integers. So that means that x would be equal to 120 plus k times 360. K is an element of the integers. Or quadrant 3. So then x would be equal to 180 plus 60 plus k times 360. Okay, so x would be equal to 240 plus k times 360. K is an element of the integers. Yeah, so actually getting the general solutions at the end is quite easy, but all the work that we had to do to get down there was sort of fairly substantial. Okay, is this making sense? Are we feeling good? Any questions? Okay. Cool, Aisha, I'm glad. Okay, and then, yeah, very important, don't forget your k times 360. K is an element of the integers. You do get a mark for that. All right, cool. Oh, good. Can you see? I'm glad you're feeling confident. Okay, so if everybody's happy with that, we can move on to the next question. You guys can obviously always come back and come and watch this and have a look at these answers again. Okay, so now this is a problem-solving question, all right? So, sorry, I just had to. I found this and I really wanted to do it with you guys. Okay, so we've been given sine P plus sine Q is 7/5, and P plus Q is 90. Without using a calculator, determine the value of sine 2p. Okay, so often we read these kinds of problem-solving questions and we're just like, what on earth is going on here? All right, so the bit about P plus Q being equal to 90, why do you think they're telling us that? What does it mean that P plus Q has to be equal to 90? Why do you think they tell us this? So angles that add up to 90 are called complementary angles, aren't they? All right, so let's have a yeah, let's consider it like this. Okay, so if P plus Q is equal to 90, if that was angle P and that was angle Q, then we'd have to be working in a right angle triangle, wouldn't we? And both P and Q would need to be acute angles. All right, does that make sense to everybody? Okay, so they're both acute, they're complementary. We must be working in a right angle triangle. Lovely. All right, so now they give us sine P plus sine Q equals 7/5. So clearly that is some kind of equation that they've given us that they want us to try and manipulate. What they want us to do is they want us to find an answer that is in terms of P. So if they want us to provide an answer that is in terms of P, what we needed to do is try and think about how we could rewrite this in a different way. Okay, we've got to try and write it in terms of P. So how could we rewrite sine Q in terms of P? Any ideas? And you know what? It's one of those things that, like, when you figure out what you're supposed to do, it's so obvious. But at the time we think to ourselves, oh, this is so difficult. What are we supposed to be doing here? You know what, Cornelia, when I first saw this question, I also thought about that. I also thought about taking the sine Q over to the other side. But then that's not what I did. You know what? I'll tell you what I did is you can rewrite sine Q, because if we're working in a right angle triangle, then you know that the sine of P is the same as the cos of Q, because P and Q are complementary, aren't they? Which means that the sine of Q is going to be the same as the cos of P. Does that make sense? Does that make sense to you? Okay. Now, again, I can see here. So SL Bavuma, Colofelo, Rachel, we're all doing what, yeah. So, yeah, that's exactly it. That's exactly it. Okay. So, in other words, hope you're saying no. Okay. Hope, it's okay. Let's have a look at this right angle triangle, Hope. Okay, if this is angle P over here, and this is angle Q over there, right? If I call, let's look at it this way. Hope, if I call this side A and that side B and this side C, right? The sine, let's just talk about this one specifically. The sine of angle Q is going to be opposite over hypotenuse, isn't it? So sine Q is A over C. All right. If I now talk about the cos of angle P, Hope, P is now this angle over here. It's adjacent over hypotenuse. It's A over C. Okay, so that's exactly right. Okay, so the sine of Q is the same as the cos of P. So what we're going to do here is we're going to write sine P plus cos P, because sine Q and cos P are the same, is equal to 7 over 5. Okay, does that make sense now? Okay, so it's grade 11 work. Okay, so we're always, so sometimes things are, they seem so difficult, but meanwhile, it's just like a grade 11 thing. And now I'm going to do something that you probably wouldn't have thought of, but I'm going to square both sides. All right. And the reason why I want to square both sides is because when I've got sine P plus cos P in brackets, all right, I'm going to end up by multiplying, I'm just going to do this the long way, sine P times cos P by sine P plus cos P. And when I do that, I've got 49 over 25 here, I'm going to end up with my middle term, my O and my I from FOIL is going to be 2 sine P cos P, which is sine 2P. Right, so I'm just going to say that again slowly. So I'm going to FOIL out my brackets. That's going to give me sine squared P. Then sine P times cos P is sine P cos P. Cos P times sine P is also sine P cos P, plus last times last, cos squared P equals 49 over 25. So now, matrix, you've got sine squared P plus 2 sine P cos P, which is sine 2P, isn't it? Plus cos squared P equals 49 out of 25. And then again, yes, then we can get to identities. All right. So here, sine squared P plus cos squared P is also an identity, isn't it? It's equal to 1. So now you've got 2 sine P cos P plus 1 equals 49 over 25. Take the 1 over to the other side. And then what we're going to do is we're going to write 2 sine P cos P as sine 2P. And that's going to be equal to 49 over 25 minus 1. Okay, so 49 over 25 minus 1 is going to leave us with a negative answer, isn't it? Minus 1. Oh, no, it's not negative. Sorry, I'm being stupid because it would be 25 over 25. That's right. Okay, so the answer would be 24 over 25. Okay. It's crazy, eh? All right, but I want to show you these things so that you can think in this way, you know, so that you've been exposed to it. And if you see stuff like this, that you're willing to try these things in tests and exams. Okay, so it's really important. One of the things that, you know, if you've got sine P plus cos P and you square it, it's really important to note that the result from that is sine 2P plus 1. Okay, and when you know that, yeah, being able to answer something like this becomes a little bit easier. Okay, all right, so there's a little bit of problem solving. Let's jump in, and I know you were looking forward to doing an identity, so let's have a look at this one. So again, I haven't chosen the easiest thing. I've tried to choose something that is difficult. Yes, Michelle, 2 sine p cos p is your sine double angle identity. Okay. Yeah. All right, so now they want us to prove an identity, if that's all right, if we can move on to this one. All right, so they've given us this. Okay, so the first thing that we want to do when we are solving an identity is, oh, no, hang on a second, let me just reverse a little bit. When you are solving an identity, or proving an identity rather, you are not solving an equation, okay? So you cannot move terms from one side to the other. You can't cross multiply, okay? Those are things that you're allowed to do when you're solving an equation. So when you are proving an identity, you are treating the left-hand side and the right-hand side as 2 separate things. And you must work with the left-hand side separately and manipulate it, obviously, mathematically correctly, so that it looks like the right-hand side. Okay, or sometimes you can work with both the left and the right, but you've got to do that independently of one another. Okay, so very, very important that it is. So, yes, Hope. Yeah, sorry, Neliswa.
Hope wanted you to scroll up.
Yes, that's fine. Okay, so there, Hope, you're going to have to do that one, and then I'll have to move it down for you. Okay, and then I'm just going to move it down. Okay, Hope. There we go. Yeah, absolutely. All right. Where were we? Okay. So, yeah, we've got to work with the left and the right-hand side independently of one another. So the first thing that we want to do is pick a side that we're going to work with. And in this case, I think we're going to work with the left-hand side. So we would write left-hand side equals, and now we've got cos x plus sine x all over cos x minus sine x minus cos x minus sine x over cos x plus sine x. Right, what do you guys think? Pleasure, Hope. What do you think we should do here? What are we working with?
Ma'am, we can get the LCD.
That's it. Okay, well done, Cornelia. All right, so they are fractions. We want a lowest common denominator. You're quite right. Cornelia, if you want to try and get to the answer faster than I'm explaining it, you're welcome to shoot ahead. Okay, so quite right.
Ma'am,
it's
a question we got it from the last paper, so I understand how this question goes.
Okay, all right, well done. So cos x minus sine x, and we're going to multiply that with cos x plus sine x. So that's going to be our lowest common denominator. All right, so what we multiply the one fraction by at the bottom, we've got to multiply, what we multiply the denominator by, we've got to multiply the numerator by. So that means that at the top here, we've got cos x plus sine x multiplied by itself. And over here, we've got cos x minus sine x also multiplied by itself. Does that make sense to everybody? Now, this is the bit where it becomes quite long. All right, so I'm going to put my equal sign all the way over there. Now, what I'm going to do, just to try and make things a little bit shorter, is I'm going to square a binomial. Okay, so I hope this is going to make sense to you, but I'm doing that shortcut algebra method where you square the first term, multiply the 2 terms together, double it, and then square the last term. Okay, so in other words, I'm going straight from squaring the binomial to the trinomial answer. Okay, so this would end up being cos squared x plus 2 sine x cos x. Here we're seeing that same thing again as we did in the previous question, plus sine squared x, minus, and then here I'm going to keep my brackets because I'm subtracting something that's going to have more than one term in it. And again, I would end up with cos squared x, and then it would be minus 2 sine x cos x plus sine squared x. Okay, is everybody happy with where the numerator comes from? Are there any questions about that before we move on? Oh, well done, Mohammed. Understood. Okay, all right, good stuff. Okay, so now are you happy that if we then remove these brackets and subtracted, what we would end up with is the cos squared x minus cos squared x would be 0. Sine squared x minus sine squared x would be 0. So we would end up with 4, because it would be 2 plus 2 sine x. Sorry, so 2 sine x cos x plus 2 sine x cos x, which would give us 4 sine x cos x. Excuse me, all over. And then what I'm going to do here is I'm actually going to multiply my brackets together. So at the denominator, if I multiply cos x minus sine x with cos x plus sine x, I end up with, because it's difference of squares, I end up with cos squared x minus sine squared x. Okay, and from here on, these are both double angle identities. So what I'm going to do is I'm going to write the 4 at the top as 2 times 2 sine x cos x. At the bottom, I'll just leave it like this for now. So cos squared x minus sine squared x. So at the top, I've now got 2 sine 2x. So my double angle sine identity. And at the bottom, I've got my cosine double angle identity. Remember, cos squared x minus sine squared x is cos 2x. All right. And then that would leave us with 2 tan 2x. And the left-hand side is now equal to the right-hand side. Okay. Are we feeling good? They're making sense to everybody. Lovely. Oh, good, Aisha. I'm glad. Cool. Thanks, Kanisile. All right, so that was that one. That was that identity. Okay, Michelle. Okay, so where did I lose you? Okay, so Michelle, you said the last couple of steps. All right, so Michelle, what I've done here is I've written this 4 over here as 2 times 2. And I've done that so that I can say that 2 sine x cos x is sine 2x. Okay, so that's why I split the 4 into 2 times 2. And then here at the bottom, cos squared x minus sine squared x is one of my cosine double angle identities. All right, so I applied. Oh, for the first step. Which, oh, sorry, Michelle, which step did I, the very, very first step?
Yeah.
Okay, so in other words, do you mean this line over here where I'm highlighting the equal sign in green? Oh, the numerator being squared. Okay. All right. So Do you remember from the previous question, cos x plus sine x, when we squared our bracket? So like here, when we did this sine p plus cos p squared, it's exactly the same thing as this. So like here, we ended up with sine squared p plus 2 sine p cos p plus cos squared p. It's exactly the same thing. Okay, except we're just working in terms of x instead of p. So cos squared x plus 2 sine x cos x plus sine squared x, it's exactly the same thing. Does that make sense now, Michelle? Why did we square? Okay, all right, fine. So what I'm doing here, Michelle, is I'm creating equivalent fractions. So at the bottom here, I'm going to multiply that with cos x plus sine x. So what I multiply the bottom by, I've got to multiply the top with the same thing. Okay, do you see now why it's squared? And then the same thing on this side. I'm going to take that and I'm going to multiply this by cos x minus sine x. So what I do to the bottom, I've got to do to the top. That's why I wrote it as a square. Yeah, it's all built on the basics. Okay, does that make sense now, Michelle? Cool. All right, good stuff. Okay. Okay, that was the question I wanted to show you, but okay, so I get you guys can choose. We can do a different type of general solution if you want, or we can do this problem solving question. What would you prefer? Do you want to try a general solution on your own? Okay, so can you see Lisa's problem solving? Taniko says problem. Oh, shame. Okay. All right, well, let's see if we can. Okay, so there's about half and half. Okay, well, tell you what, let's see if we can try and squeeze. Yeah. So the problem solving question is this one, Cornelia. So evaluate without using a calculator. All right. Okay, so I tell you what, let's. Okay, all right. So there seem to be more people saying problem solving. So we'll go with that. I could hopefully go back and do the other one with you as well. Okay, so if they give you something like this in trials, so you've been asked to evaluate without using a calculator, right? And this is sigma notation, isn't it? Okay, from paper number 1. So when we're working with sigma notation, what does it mean? So if we've got a situation like this where we've got the sigma symbol and we've got a number at the bottom, so like n equals 1, and then we've got a number at the top, so let's pretend the number is 8, and then over here you've got a rule like 2n plus 3. What are they asking us to do? What does the number at the bottom represent? Exactly, Pumeza. So in other words, we've got to sub in. So in other words, the number at the bottom, this is where we start subbing in. And the number at the top, this is where we finish subbing in. All right, so what this means is take 2 multiplied by 1, add 3, and then add that to 2 times 2 plus 3. Okay, and continue to do that until we've subbed in 8. Okay, and then what we're going to do is we're going to add all of those together and we're going to get some number. That's what sigma notation means for us. So it's exactly the same thing here. All right, that's exactly what they want us to do. We've got a place where we're going to start subbing in, and we've got a place where we're going to finish subbing in. All right, so getting rid of, and obviously the number at the top minus the number at the bottom plus 1 gives us the number of terms, but we don't really have to worry about the number of, well, mind just because we do need to worry about the number of terms, but I'm going to show you how we would do that. Okay, so we've got our rule, cos squared A. So we've got cos squared, and in place of A, we've got 38 degrees. All right, then we're going to sub in the next number. So that would give us cos squared 39 degrees plus cos squared 40. And so we would go on and on and on. And eventually we would end up at cos squared 50 plus cos squared 51 plus cos squared 52. And that's where our series ends. So now that we've expanded all of this, we're looking at it and we're saying to ourselves, they want us to evaluate this without using a calculator. So there must be some kind of pattern. Something's got to be going on here that we can use, where we don't need a calculator. So again, this is the importance of your co-functions, right? So look at those two numbers. What do they add up to? Okay, that's not by coincidence. 39 and 51 also add up to 90. Okay, so when we've got complementary angles, it means we can write cos in square in terms of sine or sine in terms of cos. So in other words, if we now choose to keep the beginning bit the same, okay, so cos squared 38 plus cos squared 39 plus cos squared 40, what we can do is we can start changing the end. So in other words, cos squared 52 is the same as sine squared 38. Okay. And cos squared 51 is the same as sine squared 39. And cos squared 50 is the same as sine squared 40. And so we would continue to go back like this. Yeah, absolutely. Isn't it amazing? I love maths, Cornelia. It's so clever, it's so simple and just so elegant. And the people who think these questions up are just so smart. Yeah, I love maths. I hope you guys, when you come to these lessons, you really enjoy it and love it as well. Okay, so now, using what we know from grade 11, we know that cos squared 38 plus sine squared 38 is going to be equal to 1. All right, and same thing here. So we've got cos squared 39 plus sine squared 39, and that's also going to be equal to 1. And so on we would go. All right, so and then same story over here when we get to cos squared 40 plus sine squared 40, that would obviously also be equal to 1. So now what we're doing is we're kind of working our way back to the middle with all these ones. All right, so how many ones are we going to have and what's in the middle? So we have 8 pairs of angles that add up to 90. Okay, so we've got the 38s, the 39s, the 40s, the 41s, the 42s, the 43s, and the 44s. What's going to happen when we get to the middle? We're going to end up, if we work from the left to the right, we're going to end up with what in the middle? Yeah, we are going to end up with special angles, but what's going to be the middle term? Yeah, so in other words, cos squared 45 is going to be the middle term. All right, so what you're going to have in the middle, essentially, if you guys can imagine this, let me write it in a different color, is you're going to end up with cos squared 45 on its own in the middle. And to the left over here, we're going to have cos squared 44. And to the right over here, we're going to end up with sine squared 44. Does that make sense to everybody? Okay, so this is what fits into this middle bit over here. So we've got the 38s, the 39s, the 40s, 41, 42, 43, and 44 that adds up to 1. Plus, we've got this cos squared 45 in the middle. Does that make sense to everybody? So we've got 7 groups of 1 plus cos squared 45. Are we all good with that? Let's just see what you guys are saying in the chat. Yes. Yeah, you would, wouldn't you? But yeah, well, you've counted 45 twice, but it's going to be on its own in the middle, isn't it? With cos squared 44 on the one side and sine squared 44 on the other. Okay, and now, like someone said, I don't know if it was Aisha, whoever it was, we're going to use special angles. So we know that the cos of 45 is root 2 over 2. We're going to square it. So we're now going to end up with 7 plus, and that would give us 2 over 4, which is a half. So the final answer must be 7.5. Sure. So in other words, the blue bits at the ends, cos squared 38 plus sine squared 38 is going to give you 1. And then cos squared 39 and sine squared 39 is going to give you 1. So what you've essentially got is you've got the sine squared 38, cos squared 38 makes 1. Cos squared 39, sine squared 39 makes another 1. Cos squared 40, sine squared 40 makes another 1. Okay, so then it would be the 38s, the 39s, 40s, 41, 42, 43, 44. It would be 7 1s that you'd end up with, and then your middle term is that cos squared 45. Does that make sense? Can you see, Leah?
Sorry, ma'am.
Yes, Cornelia.
Can I just find out, is there another problem-solving question that you might have?
Not in this lesson today, but I can get plenty for you if you want. It just depends on if you want more.
Yes, please, ma'am. I'll genuinely love it.
Yeah, no, absolutely. I mean, I love problem solving. So, you know, whenever I see something that I've never tried before, it's always, yeah, it's exciting to be able to work through it. Okay, so yeah, I want you guys to see these sorts of questions so that, yeah, you begin to think like this and you can maybe try and answer some of these questions. But sure, I'll find something. I've got so much stuff. So yeah, I'll share it with you.
And ma'am, what about the WhatsApp group that we try to organize?
Oh, I didn't even ask them about it yet. Sorry, Cornelia. I will ask. Okay. Yeah, because it would be a nice way to be able to share resources.
Yes, ma'am.
Okay, I'll go and ask. All right, sorry about that. Okay. All right, so there you go, Johannes. So I'm saying the answer is 7.5. Okay, Johannes. All right, and then what I'm going to try and do now, because we've just got a few minutes left, is I'm going to go back up here and I'm going to go to this question. All right, because yes, it was, wasn't it? Nice problem solving. Okay, so what I want you to do is I want you to have a look at this. Consider f of x equals sine x plus 25 cos 15 minus cos x plus 25 sine 15. What is that when you look at it? What do you see? Yeah, sure, it's a function. I agree with you. So in other words, what they want you to do is they want you to take the sine of x plus 25 cos 15 minus the cos of x plus 25 sine 15, and they want you to make it equal to the tan of 165 in order to be able to do the general solution. Right? They're not double angles, Cassandra. Okay, and this is maybe where, hang on a second, let me just go. There it is. Okay, I should have maybe put this in our lesson as well, but I didn't. Okay, can you see, now that I put this over here, that it is a sine compound angle? Do you see that? Okay, so it's specifically, it's this one here. Look. Okay, so sine A cos B minus cos A sine B. Can you see now? Yeah, compound angles. All right, so when it comes to compound angles, like it does with double angles, all right, if they give us the expansion, then they want us to do the reversal of the expansion. Or if they've given us the reversal of the expansion, they want us to expand it. So here, they've given us what's on the right, and they want us to do what's on the left. Okay, so I'm just going to delete that now. And we're going to use our sine compound angle identity. Remember, sine keeps its sign. Okay, so I'm going to write this as sine, and it's going to be x plus 25 minus 15. Okay, remember, sine keeps its sign, and that's going to be equal to the tan of 165. Now, what I would do with that is the tan of 165 is it's obviously a ratio. The ratio that it's equal to is -2 plus root 3, which if you press your SD button, it ends up being this -0.267, which you obviously wouldn't be able to round off, but you don't have to work with it as this, because you can leave it as that third, 949, blah, 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 blah. And then on the left-hand side over here, we could then write this as the sine of x plus 10. So 25 minus 15, okay, would be equal to -2 plus root 3. Okay, so that means that we've got the sine of an angle is a ratio. So now we're ready to find our PAA. Remember, we're not allowed to use the negative when we find our PAA. All right, so that means we have to work with a positive answer in order to be able to get the PAA. So find the PAA, tell me what you get. What PAA are you guys getting? Or so you're working out your reference angle or key angle? Oh, so PAA stands for positive acute angle. Okay. Okay, but not negative, Kulani, not negative. Okay, remember you use the negative, all right, to determine which quadrants you're working in. Your PAA is always positive, okay? So it's got to be positive. All right, so it's positive 15,54 degrees. Okay, so yeah. All right, so now in which two quadrants is sine x negative? Sine x is negative in quadrants 3 and 4. Okay, so now this is what we're going to do in quadrant 3. Let's just move this down a little bit here. Just going to get rid of that and get rid of that. Okay, so in quadrant 3, our angle is x plus 10 equals, quadrant 3 means 180 plus our key angle or our reference angle, plus multiples because we're talking about sine. 360, k is an element of the integers. Okay, so now we've got to take the 10 over to the other side, and this would leave us with 185,54 plus k times 360. Okay. Or quadrant 4, our angle x plus 10 is equal to 360 minus our PAA. All right, so then in that case, x would be equal to 334,46. Okay.
I'm terribly sorry, ma'am, but how did you know that 10165 was that specifically?
I just put it straight into my calculator.
Oh, so you can use a calculator.
Oh, absolutely, absolutely, absolutely. Because this is a general,
okay.
This is a general solution. Absolutely. Yeah.
Thank you, ma'am.
Yeah, no problem. Use your calculator. Fine with this question. Cool. I'm glad you asked. All right, guys. So at least we managed to do a little bit of problem solving, and we managed to fit in this general solution that had a compound angle in it as well. So sorry, it was a little bit of a rush here at the end to do this, but I just wanted to get it done for you. Okay. Okay, so Rachel, when you are working with PAA, you've got to work with a positive, all right? So what I would do is this. I would say on my calculator, I would press tan 165, press equals, and now press times -1 to make it positive. So now you've got 2 minus √3 on your calculator, that's your PAA, and now you're going to go shift, sign, answer, equals. Okay, does that make sense? Yeah, shift sign, because remember you want to calculate an angle. So if you multiply your ratio by -1, that'll make it positive, and then you can just go shift sign, answer, and press equals, and then that'll give you your PAA.